Alrighty. The first thing we're going to discuss is conversions, because in the real world, we use conversions all the time. For example, you are all sitting in a 3-year-old school. This school was built from plans. Were those plans life-sized?
Nope.
Of course not. They were small. They then used conversions to build this building. All right? That is the math skill you have. But to do that skill, you must understand what is going on. And since we live in Canada, in grade 9, we start only working with metric measurements. Now, metric is not the proper name of the system. The name of the system is actually Système International, or the SI system, which was invented by French people. But because Americans hate everything French, they refuse to change to the system. It is called metric because it is based on the meter. Okay? How long is a meter? The meter is how far light will travel in 350 billionth of a second. I can't remember exactly what the ratio is. We have used various definitions to define a meter since the system was invented. Originally, it was the distance around the Earth divided by something, and then it was the distance from the North Pole to the equator divided by something, and then eventually they started using the speed of light. Why? Because the speed of light is constant. Everywhere in the universe, the speed of light is always the same. So they started using the speed of light. Everybody cool?
Yep.
Every measurement we have in the metric system, the SI system, is based on a fraction of 10, which is based on the meter. Everyone understand that? We use 10 because 10 is how we count. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 digits in how we count, 0 through 9. So it made sense to measure in those same base of 10 chunks. Everyone got it?
Yep.
Now Americans, of course, and anybody who is still using the old system, doesn't realize how stupid it is. Because, of course, it is difficult to work in that old system because 12 inches equals 1 foot, but 3 feet equals 1 yard, but 1,760 yards equal 1 mile, and 5,280 feet equal 1 mile. So, of course, it makes it very easy to do the math. It doesn't. It's a pain in the butt, and it's stupid. Metric, everything is times 10 or divided by 10. It's that easy. Got it? Now, this here is a ratio. And that ratio, if you remember back in the day, you can write this as for every 1 meter, you get 100 centimeters. 1 meter to 100 centimeters. Everyone cool? What's the other way you can write a ratio? A slash, 1 to 100. And what's the other way we write that in math class? 1 over 100. So all of those are the same thing, yeah? All right. So if I was going meters to millimeters, what would the ratio be? 1 over 1,000. Now here's where it gets weird. What if I go the other way? Do you think I change what I am doing? No. This would be 1 over 0.01, which makes no sense, does it?
No.
But if you follow along, it does. Everybody with me on this?
Yep.
Okay. Now the next thing you have to remember is in the metric system, what tells you the size of the fraction? Is it the M or the C? The C. Centimeter. Cent, 1/100th. 1/100th of a dollar. Because cent, C-E-N-T, is 100 en français. Okay? That is why Celsius is actually centigrade. because it goes from 0 to 100, freezing to boiling water. Cent. Okay? Percent, per 100. So we divide by 100 to get cent, percents. Everybody good? Okay. So, milli is French for 1,000. Mille, M-I-L-L-E. 1,000. Everybody cool? So it's this letter that tells you the fraction you're going to use. So if you're going meters to centimeters, you must need 1/100th. Right? 1 divided by 100. What if I'm going centimeters to meters? I'm going the other way, so what math would I be doing? Multiply by 100. Picking up what I'm putting down? That's how easy the metric system is. Okay? So now here we're going to list all the measurements that we actually use in metric. I'm going to list them in red. So you guys are aware of millimeters, right? And milli is 1,000th, which we have right here, 1/1,000th, meters to millimeters, yeah? Got that right here. That's 1/1,000th. What's the next one up for millimeters?
Centimeters.
Centimeters, which we also use. Now, I've told you it goes up by chunks of 10, yeah? So this must be 1/100th, because it's multiplying, correct? Now, does anybody know the next one, which I'm going to do in blue, because it's one we don't use in Canada, but we use it everywhere else in the world? Where would we go from centimeters in reality? We go to meters, don't we? I'm 1 meter and then 73 centimeters taller, yeah? But you guys are smart kids. Milli, 1,000th, centi, 100th. We must need what in the middle here? No, inches are not metric. I need a 10th, don't I? Just looking at the pattern, you know you need a 10th. What do you think it is? Everywhere in the world except Canada uses it. Milli, centi. Milli is 1,000, centi is 100. What do you think is French for 10? Dix, D-I-X. Decimals. This is a decimeter.
Oh, I've heard of those before.
Deci, which means 1/10. Decimal, 1/10. Everybody cool? So that's probably new to most of you. Most of you probably haven't heard of a decimeter, but they use it in the everywhere in the world that uses metric except here. Now, what's next? It's one we actually use. Meter. It's our base one. So that's 1/1, so it's just 1, yeah?
Yep.
Okay, now you guys are smart kids. 1/1,000, 1/100, 1/10. So the next one must be, I'm going up times 10 each time, aren't I?
Yes.
So the next one must be a meter times 10, correct? It's not a measurement we use. Does anybody want to guess what it is? You already know deci is 1/10. What do you think 10 is? Like 10 years. A 10-sided figure.
10? What? I don't know.
What do you call a period of time that's 10 years? You guys don't know?
Oh, wait,
A decade. So the next one, and again I'm going to do it in blue because it's not one we ever used, is what's called a decameter. Decade. But we abbreviate it as DAM.
I like that one.
And that's 10 meters. Cool?
Yep.
So it's not 1/10, it's 10/1, isn't it?
Yeah.
Now, you guys are smart kids. What must the next one be? 100/1.
Which is, wait, what? I remember.
It's not one we ever use until I explain it. It's going to make sense to you as soon as I explain it. Nope.
I don't know why I guess.
It is hectometers, which is, how do you think it's abbreviated? HM. And we use that only in area. Because it's a hectare, which is 100 square meters. 10 by 10. Okay? No, sorry, a hectare is 100 by 100.
Yeah.
So it's 1,000,000 square meters. Crap, now I can't remember. I got to find out how big a hectare is. See, sometimes my brain doesn't work. So what do? Go to the internet and find the information. Am I going to type in balls on picket fences? No, I'm going to type in actual information. Hectare. 10,000 square meters, so it's 100 by 100. So a hectare is 100 meters by 100 meters. That's when we use hectometers. We don't use them any other time. That's why they're blue. And then the next one you do know, what is it?
Kilometers.
Kilometers. KM. Kilo. And that is, of course, 1,000 over 1. All the red ones we use. Now, we do still use other measurements. For example, are there measurements smaller than a millimeter? Yeah, it's a millionth of a meter, or a 10,000th of a meter, which is a micrometer, and then a nanometer, and then a picometer. Then we get smaller and smaller and smaller. Going the other way, what's next after kilo? Think of computers. Kilobyte, megabyte, gigabyte, terabyte, and that's where we stop. Even though there's more words.
Is there like supercalifragilistic?
Well, again, you could go to your friend Google and say giga, tera. I think the next one is petabyte. Petabyte and all that. I don't care, because that's too big a number to be of any use to me. Unless, of course, that was on Jeopardy, but Canadians can't go on Jeopardy anymore, so.
What?
They changed the rules, which is ironic because, of course, Alex Trebek is a Canadian. So, convert each measurement to centimeters. Okay, so here's how you do it. You don't have to memorize this. You will always get this. You know that 1 meter equals 100 centimeters, correct? Right?
Yep.
Okay, so here's what you do. You take the measurement you have, and you multiply it by the ratio. But the ratio has to be written specially. I'm going to write it in red. We write the ratio like this. What we want over what we have. So, in this case, I have what I want, 7. See how I've got it right here? And then I am multiplying by the ratio. What do I want? Centimeters or meters? I want centimeters, so I have to put the 100 on top and the 1 on the bottom. What is 7 times 100? 700 centimeters. Does everyone see how it works? Okay, now if you're smart, you also recognize that isn't 100 over 1 just 100? So isn't this just 7 times 100? Yes. But this fraction thing, this thing, will help you out next year when you are working on taking American measurements and making them metric, or taking metric measurements and making them American. Okay? So this is useful because it will always work in metric, imperial, and between the two. This is really only good in metric. Okay? Yes?
I remember, I don't know if this is relevant, but like that reminded me about like if you have been driving in the States.
Yes.
Do they have like a different
Yes.
They have a different thing?
Yes, because they measure in miles. No. And I have a funny story about that. I was driving across the United States, and it was about 4 in the morning. I was like, because we drove all the way to Georgia, and we only had 2 weeks to do it, so we had to drive like 20 hours a day to make it there if we'd have to have time to visit and do stuff. So we're driving. My wife's already asleep, She's in the passenger seat. And I look down at my gas gauge and the odometer, and I know that my gas tank will go 600 kilometers. And every time I fill it, I would reset it. So I look down at my gas gauge, and it's at 420 kilometers. So I know I got 180 kilometers left to go, right? So I'm driving along, we're in Montana. Now, if you've been in Montana, Montana is a strange part of the universe where distances stretch. Because Montana is giant, but there's nothing in it. So it feels bigger than it is. So I'm driving through Montana. Oh, I can go 180 more kilometers. Okay. Road sign. Goes driving up to the road sign. 120. Oh, yeah, okay, I can get there. Look down at my gas gauge. Coming up to around 600. Look over at my needle. Down near empty. Look around Montana. Nothing! What the hell? Why isn't there a gas station? Because the 120 on the road sign was not kilometers. It was miles. So I was stuck in the middle of Montana with no gas. And sleeping life. So, I got in trouble. Parked the car and walked and got gas. Anyway, in reality, this happened in a much more horrible situation. An American plane landed in Montreal. It had to fly to Vancouver. So they filled it with fuel. But they filled it with enough fuel doing the wrong measurements. They filled it with enough fuel to fly a certain amount in Imperial. They didn't give it enough fuel to fly to Vancouver in metric. So the plane had to crash in Lake Winnipeg. It's okay, everyone lived, but he had to land in the water because one idiot couldn't do grade 9 math. I'll give you another example. You remember how Target failed? Remember when Target came out, they were going to save the day, be the greatest Canadian realtor ever, and then they were gone in a year? That's because the morons that run Target in America brought all their stuff from America to Canada, including the measurements of their shelves. And the idiots forgot we're metric. So every Canadian, that's why their shelves were always empty. Because the stuff that they wanted to put in the shelves didn't fit. Because the shelves were measured in metric, and the stuff they had was measured in imperial. And nobody in that billion, it cost the company $1 billion because they didn't pay attention in Math 9. But of course, math doesn't matter, right? Because we need to learn this. All right, so here we go. Millimeters, and I want to go millimeters to centimeters. So 1 millimeter is how many centimeters?
21.
No. Look on your chart. 1 millimeter is 0.1 of a centimeter, yes? So I go to here and I go 0.1. So I need 21 and I got to multiply by, what do I want? I want the centimeters on top, don't I?
Yeah.
So it's 0.1 over 1. So 21 times 0.1, what do you do with the decimal? If it was times 10, we'd move the decimal which way?
The 2 steps now.
1 step. If it's times 10, we'd move the decimal 1 step, we'd put a 0 in the hole, right? But now, we're moving the decimal the other way. So the decimal normally lives here, yeah? So it's got to move which way? Left. How many spots? 1. So it's 2.1. Picking up what I'm putting down? All right, let's go to the next one. 346 centimeters to meters. Well, 1 centimeter is how many meters? 1/100th. We did that in our chart at the top. I want meters, right?
Yeah.
So which of these is the meters? 1 meter is 100 centimeters, correct?
Yep.
So I want the meters so it stays on top, right?
Good.
So it's times 1 over 100. 346 times 1 is what? 346 divided by 100. How many places does the decimal have to move? 2, because it's 100. 3.46. Now you guys are smart kids. You recognize that 1/100th is also 0.01, isn't it? Oh, 2 decimal places. Durr, 2 decimal places. Picking up what I'm putting down? Do I care what method you use? No. Do I recommend you start with the fractions? Yes, because that will work everywhere you go. When you are good at this, you can start doing just the decimal thing, because you'll start seeing it. So, I got to go millimeters to meters, yeah? So, 1 millimeter, if a centimeter is 1 over 100, a millimeter must be 1 over 1,000, yeah? So, I have 1,800. Now, let's do the shortcut now, because we've been doing it a bit. What is 1 over 1,000? Isn't that 0.001? So can't I put that here? Now, I need those decimals to disappear. 3 steps, correct? So I need 3 steps here. Which way? Left, 1.8. Let's pretend you don't remember that in your head. Well then, you just do the math. 1,800 times 0.001, or 1,800 times 1 over 1,000, which is 1,800 divided by 1,000. Everybody good? All of those are the same thing. You already know this from grade 6 math. I know you know this from grade 6 math because my kid is doing grade 6 math right now, and they did decimals. Okay, so now these ones aren't pretty, are they? Because they've got a decimal in them already. But do you think the rules change? No. 1 centimeter is how many millimeters? 10. And I want to go to millimeters. So that means I want millimeters, don't I? So what would go on the top? Millimeters or centimeters? Millimeters. So it's going to be 6.5. I put what I want on the top, what I don't want on the bottom. 6.5 times 10 is what? 6.5 times 10. How many decimal places does 10 move it? 1. So it's 65. Everybody good? What's this one? I want to go meters to millimeters. So I know 1 meter is 1,000 millimeters. And which one goes on top? Millimeters on top, yeah? Right? So it's 3.8, what I have, times what I want, millimeters on top, over 1. 3 zeros means how many decimal places does it move? 3 times. What goes in the empty spaces? There's 1 to 38. It's got to move 3 times. What goes in the empty spots? Zeros. 3,800 millimeters. Is everybody good with conversions? Erlen. Okay. Now, obviously, remember the example I gave you at the beginning of the class. This building was originally a piece of paper, wasn't it? Was the piece of paper the size of this building? Of course not. So this building was an enlargement of the piece of paper, agreed? And the piece of paper then is a reduction of the building. Does everybody get that? Yeah. Okay. So the first thing we're going to do is we're going to do enlargements. All right? Now, there's going to be some writing right now. An enlargement. Now highlight enlargement, okay, is any model Now, does it have to be a model? No. Is a plan, a flat piece of paper, a model of this building?
Yeah.
Yes. Okay, it's a model is any representation. Okay? So, an enlargement is any model that is bigger, highlight bigger, than the original. Okay? Everybody with me?
This also.
Everybody good? Okay. So, this building started out as what? A plan on a piece of paper, yes? So this was the original thing, wasn't it? This is an enlargement of this. Everybody got it? Okay. So, here's the math that happens. All. Highlight the word all. All measurements on the original are multiplied by a scale factor. I'm going to highlight scale factor. Now you guys are smart kids. Look at all the math we just did. Did I do multiplication here? Is that a measurement? It multiplied by something, yes? So this is my scale factor. Is everybody cool? Okay? So now I'm going to show you what I actually mean. This is how you find a scale factor. All right? You take a measurement. Does it matter what measurement? No. You take any measurement from the model. Okay? So, if I took this measurement from here to here, this is a model, isn't it?
Yeah.
This was not what we started with. We started with a plan, right?
Yeah.
So we take a measurement from the model and we divide it by the measurement from the original. The same measurement. Okay? Is everybody with me? And that gives you your scale factor. Now I'm going to show you what I mean by that. You guys are smart kids. Okay? This distance distance 30, 60, 90 is 114 centimeters. Everybody cool? Everyone agree? Is that a model or an original measurement?
Model.
Model, because this thing was built from the plan, right?
Yeah.
So that was 114 centimeters, correct?
Correct.
Now, on the plan, is it 114 centimeters?
No.
Of course not. It's way smaller, isn't it? Just for fun, let's say on the plan it's 1 centimeter. Right? Everybody with me? is that division, what's the answer to that division? What's 114 divided by 1?
114.
It's 114. That number is greater than 1. What does that mean? So that means the plan multiplies by 114 to get the answer. Since it's greater than 1, we ended up with an enlargement. And we did, didn't we? Because the school is bigger than the plan. Everyone cool? Now, how many of you have ever built a model plane?
Me.
Or a model car? Or some Lego? Are those things life-sized? No. So the original is the bigger thing, isn't it? So, and the model is the littler thing, isn't it? So what would happen to this statement here if it were reversed? What would your division be? Would be less than 1. If it's less than 1, then you have a reduction. Everybody cool?
Yes.
So originally this building started as a plan, yeah? Have any of you guys seen those blueprints ever? Those plans? No. You probably haven't, right? But how often have you in your school careers done one of those projects where the teacher says, measure the room and draw it? Have you done that? Okay. In that case, the room is the original thing, isn't it? And you are creating a model from that, which is smaller. Everybody good? Okay, let's make sure everyone's good. I'm going to take a second right now, let you get that into your head. If the scale factor is bigger than 1, it's going to enlarge. If the scale factor is less than 1, it's going to get small. Everybody got it? Let me give you an example while you're thinking of this. Right now, you guys aren't aware, okay? But in 2032, when I retire, having spent my entire teaching career at Abbey Senior, they are going to go ahead and build a giant statue out there of me because I'm 100% awesome, right? Will that statue be an enlargement or a reduction of me? An enlargement. So I am 173 centimeters tall. They're going to go out there and they're going to build a statue that is 10 times the height of me. Which means, what will the height of the statue be? I'm 173 centimeters tall. Yep. 1,730 centimeters tall, yes?
Yes.
My index finger is 8 centimeters long. How big will my statue's index finger be?
Very long.
80. Why? Because every measurement is times 10, yes? Now, you bring your children to the school, and they see the statue, and you say, he was my math teacher. And your kids say, no, the famous Matt Myers was your math teacher? And you're like, true story. And they're like, oh. And then they say, well, I want a souvenir. And they buy a keychain of the statue. Is that keychain an enlargement or a reduction of the original?
Reduction.
It is a reduction. It is 1/10 the size. So how tall is the keychain? 17.3. Because the scale factor is 1/10, which is less than 1. When we built the statue, it was 10, which is greater than 1.
Still pretty big.
Everybody with me? Yes, it is a big keychain because I am that awesome. Is everybody with me?
Yes.
Now, in that case, what is the original? Keychain, statue, or me?
Yeah.
Me. Statue is an enlargement, so its scale factor is bigger than 1. Keychain is a reduction, so its scale factor is less than 1. Okay? Everybody good? All right, let's see if you really get it. Here we have a pin. The actual length of the pin is 13 millimeters. Okay? So I'm going to go ahead and highlight actual length. Is this thing right here the actual pin? No. So is this thing the model or the original? This is the model. Everybody good? So remember that a scale factor is always the model over the original. Yes?
Yes.
All right. So, do we know the original length? Read the question. It's 13 millimeters. Now, since it's written in millimeters, and the units of length must be the same in scale factors must have the same units. So that means I got to now measure this model, don't I? In what measurements? Millimeters, because I have to use millimeters. So I'm going to get out my ruler just to save time, and I'm going to measure mine on my screen. It is 4.4 centimeters. So on my screen, or 4.4 centimeters, is that okay?
Yeah.
What's wrong with this?
Oh,
Centimeters and millimeters. So what do I got to do to this to get it to millimeters? We just did a whole page of it. I got to times it by 10, don't I? So it's got 44 millimeters over 13 millimeters. Does everyone see that? So what math would I do? I would divide that and I would get 44 divided by 13, 3.38. That is my scale factor. Now what does that mean? That means any measurement on this model, right, is a factor 3.38 compared to the original. Is this bigger or smaller than 1? Bigger. So is this model an enlargement or a reduction? An enlargement, because the scale factor is bigger than 1. Does everyone get it? So when I enlarged it, I multiplied. So what would I do to shrink it? Divide by the same scale factor. Everybody good?
yeah.
All right, let's see if you actually are. This guy is an ant.
Spider.
The actual length of an ant is 6 millimeters. Okay? This guy is obviously bigger than 6 millimeters, isn't he?
Because he's spider.
Somebody measure him. Nice catch. I'll hit you in the hands next time. It's the only time James has touched his paper all day, so that's why I threw him the ruler. How long is that ant, James?
3.2.
From this
Yeah.
to this was 3.2?
Centimeters.
Okay. Let's call it 3 to keep it easy. 3 centimeters, or how many millimeters? 30, right? So, the length on the scale diagram, is the scale diagram the model or is it the original? It's a model, because it's not an actual ant. It's not crawling around on the page. Over the original.
Yep.
So, what was the measurement on the model? 3 centimeters. 3 centimeters. What was the measurement on of the actual ant? 6 millimeters. What's wrong with that? They have to be the same. What are the two options here? Can I go 30 over 6? Yes, because that's times 10, and that guy's already in millimeters. Can I go 3 over 0.6?
Yes.
Yes. Do that math, and what do you get? 5. Is that greater than 1?
Yes.
Yes. So that means this is an enlargement of the real ant.
So it's the new Spider-Man movie?
Is everybody with me?
Yes.
Okay. James, if I acknowledge the fact that you've said spider-ant 17 times, will you stop saying spider-ant?
Yes.
Okay. Consider it acknowledged.
Okay.
All right. All right, let's look at the next one. Now, this is a little hard to see. It didn't photocopy very well, so I'm going to go ahead and use red. Here is my original. Now, this is a weird one because this applies theory, doesn't it? Because these are both drawings, aren't they?
Yeah.
So they're both technically models, right?
Yeah. Whoa.
Huh? Okay. So let's put this together. I'm going to do this one in green. All right, is everybody good? So, length of the rectangle in the scale diagram. So which is the scale diagram? It's been labeled for me. It's the green one. So what is its length? I've even told you what its length is. What is it? 9 centimeters. Great. And what is it in red on the original? 3. So now all I do is my math. 9 over 3, which is 3 is, so the scale factor is 3. Is that greater than 1?
Yes.
Yes. So since 3 is greater than 1, the diagram is enlarged. Now, do I need to do width?
No.
No, because every measurement multiplies by the scale factor, right? So let's check. What's this measurement? 2. I know the scale factor is 3, so I got to multiply by 3 to get what? Let's check. 1, 2, 3, 4, 5, 6. Holy crap, it worked. What would happen if I measured the diagonal? I would do Pythagoras, and I would find this. Do I need to measure this one? No, what do I know it is? Multiply this by 3. Picking up what I am putting down?
It is picked up.
Awesome. Okay, you're free to go. I counted, Erlen. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay.